All right, the movement of matter. This should look familiar. By the end of this video, hopefully you'll be able to describe how the water cycle, carbon cycle, nitrogen cycle, phosphorus cycle work within ecosystems. And we're going to add to that, be able to discuss the movement of calcium, magnesium, potassium, and sulfur within living matter and within ecosystems. The phosphorus cycle, the movement of phosphorus around our biosphere. This operates primarily between land and water. There is no gas phase, and although phosphorus does occur in the atmosphere in very tiny amounts, especially like when dust is disturbed or rainwater, sea spray by the ocean and by the beach. Unlike nitrogen, phosphorus rarely changes form at all. It typically is found in the form of PO4, 3 minus charge. We know that polyatomic ion is phosphate. There we go. PO4, 3 minus. I guess you can start to see at this point why I also teach chemistry. There's a lot of chemistry in environmental science. So perhaps you may have heard on the news that our Gulf of Mexico is what we call a dead zone. Well, how did that happen? The Mississippi River carries this nitrogen-rich material from all the fertilizers along the riverside, and that all runs off into the Gulf of Mexico. There's a population of these microscopic organisms. They feed off of this nitrogen. And so, since there's so much of it, they love it and they just grow and reproduce like crazy. And so, boom, that's how we get this algal bloom, which is this rapid increase of algae in the waterway. But, they don't like everything, it doesn't live forever. So, eventually they die and they sink to the bottom. So, their decomposition basically, that process depletes all of the oxygen that's in the water. And so fish and other sea creatures, they don't like there not being oxygen in that water. And so they usually move or they just eventually die. So what was fertilizer on one crop has depleted an entire area of life in the ocean. So what we did upstream definitely affected what we did downstream. So in short here, the phosphorus cycle, that it's usually two components. There's a biotic process that is affected by producers. So producers that are on land and in the water, they take up inorganic phosphate and assimilate that phosphorus into their tissues. As a waste product, and they eventually die, their bodies decompose by fungus and bacteria, which causes the mineralization process again, and eventually the organic phosphorus is turned back into inorganic phosphorus, phosphorus that's living in from living material to phosphorus that's living in non-living material. The abiotic process of phosphorus is involved in the movement between water and land. So in water, phosphorus is not very soluble. Much of it precipitates out of a solution and forms this like phosphate laden sediment in the ocean. It's just kind of gross. You can see this process in the corner of the diagram down here at the bottom. All right there. You see the phosphorus in the rock layer. So over geological time and the forces of nature, these ocean layers can come up. They become mountains or whatever when the plates move together. That's a whole nother unit. And these phosphate-like rocks weather against natural forces once they're exposed, like rainfall or any type of precipitation. And so when that happens, that brings out the phosphorus and it puts it into this terrestrial environment, which eventually runs off into an aquatic habitat. So phosphorus is tightly held like in soils. And also at the bottom of most water bodies. So because so little phosphorus really leaches into other parts,
Very little dissolved phosphorus is naturally available in streams, rivers, lakes, and as a result, phosphorus is what we call a limiting nutrient in many aquatic systems. Humans have dramatically affected the phosphorus cycle. We actually mine phosphate out of sediments from mountains and put it into fertilizer. These fertilizers, when they're applied to your lawn or garden or entire fields of corn, basically all this excess phosphorus can leach into water bodies. Because aquatic systems are commonly limited to this low availability of phosphorus, like in its natural state, even small, tiny amounts that are leached into the system greatly increase the growth of producers. It's like, woohoo, here's all I need. And when this input phosphorus is there, it rapidly increases the growth, and especially in algae. And that's how we get these great big blooms. When the algae die, and decompose, large amounts of oxygen are used up. And that is what we call hypoxic. Hypoxic conditions basically kill fish and everything else. Hypoxic conditions lead to dead zones. They occur everywhere in the world. Right now, the hot spot is the Mississippi River and the Gulf of Mexico. That's what you saw a few slides ago. Um, Besides fertilizers, the second major source of this phosphorus introductory is from laundry detergent. So from 1940 to 1990-ish, countries like, the United States, we basically put a ton of phosphates in our cleaner that cleaned our clothing. And then that water was discharged from our washing machines inadvertently into streams and rivers and everything else. And it created this huge dead zone anywhere around where a lot of that was taking place. And so there has been a law passed recently. I want to say 1994 was the first ban. And then as recent as in 2013, it became countrywide laws. And then just most recent here in 2017, the European Union has now banned all phosphate laundry detergents. But that's how long it took to implement those laws from a state to a national to an international level. All right, and finally, calcium, magnesium, potassium, and sulfur. Oh my, the sulfur cycle. Most sulfur exists in rocks and it's released into the environment by weather over time. So producers, they absorb sulfur through their roots most of the time through that sulfate ion, SO4, -2 charge. And then the sulfur then cycles through the food web. The sulfur cycle has a gaseous component. You can also, when volcanoes erupt, that's another source of an atmospheric sulfur ion. But human activities have also increased the amount of sulfur in the atmosphere. The burning of fossil fuels, and there's a lot of mining processes, particularly like the mining process of copper, that have increased SO2 into the atmosphere. SO2 is converted into sulfuric acid, which is H2SO4. And if you remember, when that's mixed with water, you might have learned this some time ago, we call that acid rain. So, in conclusion, here, the sulfur cycle is a weathering problem, or was a weathering cycle over time, and it's only recently kind of been a problem when we have yanked it all the way out of the ground by mining it in a very expensive manner, and then combusting it into the atmosphere through an extraction combustion process. What used to happen through volcano eruptions, which were very rare and infrequent. And now that we put that into a gaseous form and it likes to float around the atmosphere, eventually it will hit the planet once it rains into runoff and dissolving in the ocean and affecting everything that lives there